Okay, let's have a look at the exercise for this section on database performance. So we have a system built in FME Flow here where people can put in an address ID and get garbage zone pickup information. So which day garbage will be picked up at this address. And it works, but it's a bit slower than we'd like. So we're going to have a look and see if we can balance this. In this exercise, you can use either a PostGIS database or an Esri geodatabase. I'm going to go ahead and use PostGIS for this example. So I'll open the starting workspace. Which is optimized database performance. Let me make sure I open the right one. PostGIS. Note that you don't have to follow the instructions to create a web connection if you use the PostGIS example because we already have one on the machines. So you can skip. I've got a relatively simple workspace. It reads in a data set of the addresses and the garbage schedule. And then it basically looks for the address that's in the published parameter, overlays it on the garbage zone, generates a report using the HTML report generator, and then provides the result back in HTML. So let's do a test run. I'll hit run. There's already an address ID filled in we can use. Everything looks good here. You'll see we're using this database connection that already exists on this machine. Don't need to change that. So I'll hit run. And this isn't probably the best test because I'm using PostGIS over the network and I have feature caching on, but let's take a look at how long that took. So that took 6.5 seconds in that run there. You can have a look at the result if you want, just to see how the workspace functions. So it returns HTML, which reports the garbage delivery day for this address. So that's the ID, address, garbage zone, etc. So pretty straightforward. So let's see if we can improve the function here. Well, one thing we can see immediately is we're going from 13,500 points to 1 quite quickly. We should try to do this filtering on the reader. So let's see, we could use an SQL creator transformer, or we could use the where clause in this table. So in this case, let's just use the where clause. I'll put in address ID in quotes equals, and then we'll use the user parameter, which could be accessed with a $, address ID. So I'll click OK, and let's just test run that. We should just get one feature now rather than all of the features. And it should be faster. So there we go, just one. I can now delete my tester. I no longer need it. Just going to save my workspace. Sorry, lab's a little sluggish. Okay, let's rerun that and see what time we get. So it was 6.5 seconds earlier. I suppose maybe using the geodatabase might be a bit more sensible here, because right now what will happen is we'll all be hitting this database at the same time, which might have an impact. But anyway, it does seem to be a lot faster, 2.5 seconds, right? I shaved off over half, it looks like, by filtering on read. That's a pretty important step. If you wanted to, you could use an SQL creator here instead of the where clause. So I can add an SQL creator. We'll read from PostGIS, and we'll use the existing database connection. For the statement, I'll do select everything from, you could use, I guess maybe I should use, just so I don't do a typo, I'll use the double click method here to make sure I don't have any typos. So that will be my SQL statement. One thing to note with the SQL creator, you do also have to specify the attributes to expose here. You could do that manually by typing them in, but you can actually also populate them from an SQL query. And so here I can do that. I should just remove my where clause. It just basically wants the table to get the schema. So I can click OK, and that will do a quick SQL query just to get the names of the attributes. So I don't have to do that myself. Note, of course, though, that they are hard coded here. So if you wanted to change the SQL statement later, you will also have to update the attributes to expose. So click OK there. And then if we wanted to do a little test, I can send my result over here, and let's disable this section of the workspace and see if it's any different. It'll probably be pretty similar, I would guess, maybe even the same. So yeah, actually it was a little faster, but I don't know if we ran this many times, took the average, I'm not sure if it would be much different, but it is a bit quicker there. Yeah, so that's a great question. Why can't FME just take the schema from the query? So this is a kind of a key thing about how FME works, is that generally FME assumes a fixed schema that's known at author time. And SQL statements, in theory, it's kind of easy to pick from that what the attributes are. But for example, it doesn't, in any situation in FME where you're retrieving data from some external source like that, not through a reader, you're going to have to specify which attributes are going to be exposed. It will read the attributes in as unexposed attributes, but they won't be available to use in any transformers. And so you do have to manually expose them. It's similar to if you use an HTTP caller and get JSON back, you're going to have to specify which attributes to expose. If you're using Python even to get the stuff out of Python, you're going to have to say which attributes to expose. And these are fixed and written in the attributes to expose parameter. And that's just basically because of how FME functions. It needs to know the schema at author time. That said, there's a whole exception to that, which is the idea of dynamic workspaces. So we do have ways of building workspaces that don't need the schema to be known in advance. It's just quite a bit more complex to set up. And that's what we focus on primarily in part 2 of this course. We look at dynamic workspaces. So yeah, currently can't populate it from the query. Yeah, I do agree. It is a bit strange that you have to do a second one. That's why it like puts it in here for you. I guess it doesn't want to assume that you're going to want to expose every attribute basically that's in your query. I don't know. It is a bit funny. I suppose from a usability perspective, I should make a note of that. It doesn't make a lot of sense, I guess, to have to do it twice. I'm sure if I asked a developer about it, they'd have some logical reason, but yeah, it does seem a bit funny, right, to have to put it in 2 times. Yeah, anyway, that's that exercise. We don't really get into writing in this exercise because it's just, like I said, it gets a lot more complicated and depends a lot on what format you're using and how your database is set up and where it is and all that stuff. So we're not going to go over that, but we'll at least go over some of the basics here about reading using SQL transformers. So yeah, go ahead and work on that exercise. And did I miss a break? I think I did. Yeah, I missed a break. How are we doing for time? Pretty good. I think we can do. Oh my gosh, sorry, that was loud. So I think um, we can do another 10-minute break. So let's do that now, and then we'll come back and just do the compare workspaces. It doesn't take super long to do compare workspaces. So go ahead, take a 10-minute break, and then come back and work on this exercise. I'll quickly talk about flow performance, and then we'll do compare workspaces to wrap up the day. Thanks.